In this lesson, we will be graphing logarithms. Since exponential and logarithmic functions, since they're inverses of each other, then their graphs will be reflections across the line y equals x, the identity function. Let's first take a look at exponential graphs, the graphs of exponential functions. Take, for example, y equals 2 to the x power. The domain is all real numbers. X can have any value. The range is going to go from 0 to infinity. Anytime regardless of what number you plug in for x, you will never get a negative number for y. So if you plugged in 0 for x, 2 to the 0 power is 1. If you plugged in 1 for x, you get 2 to the first power, which is 2. You plug in 3 for x, you get 2 to the third power, which is 8. If you graph all three of those points, you have some foundational points for the graph of y equals 2 to the x power. That is typically what an exponential function, the graph of an exponential function looks like. Now if we take a look at a logarithmic function, which again is an inverse, we have y equals the log base 2 of x. Then, as is the case in all inverses, what is the domain for one function is the range for the inverse. What's the range for one function is the domain for its inverse. And the coordinates will be interchanged. So what was the x coordinates are now the y coordinates. We graph those coordinates, we see the graph of the logarithmic function, and if we add the identity function, we see that it's a mirror image of the exponential function. Now that last example was a base that was greater 1 or greater. Now we want to take a look at what the graphs look like whenever we have a base between 0 and 1. So let's use y equals 1/2 to the x power. The domain is still all real numbers. The range is still from 0 to infinity. If I plug in 0 for x, anything to the 0 power is just 1. If I plug in -1 for x, that would, to make that negative exponent positive, we would take the reciprocal of the base, so we'd have 2 to the positive 1 power, which is just 2. 1/2 to the -3 power would be 8. We graph those coordinates. You can see that the graph looks a little bit different than the graph whenever we have a exponential function with a base of 1 or greater. And if we take a look at the logarithmic comparison, we have y equals log base 1/2 of x. Again, the range and the domains will be flip-flopped. The x and y coordinates will be interchanged. And when we graph those coordinates, it is still a mirror image across the identity function. Alright, so graphing logarithmic functions. We saw what the basic graph of a log looks like. And we remember from previous lessons that anytime you add or subtract something to a function inside the parentheses, it moves it in the opposite direction, left or right. So if we have a -1 inside the parentheses, it's going to move it 1 unit to the right. And anything that's being added to the outside of the parentheses is going to shift the graph up or down. Positive is going to shift it up, negative is going to shift it down. So for this function, we have x -1 inside the parentheses, so that's going to shift it 1 unit to the right. And we've got a -2 outside of the parentheses, so that's going to shift it 2 units down. And what we can use as a marker is that coordinate 1, 0. So where that coordinate was 1, 0, we would be adding, since it's going to shift it to the right 1 unit, we would add 1 to the x coordinate, and it's going to shift down 2 units. We would subtract 2 from that y coordinate. So where that coordinate 1, 0 was, it will now be at 2, negative 2. And that's what the graph would look like. The domain, as you can see, it goes from 1 to positive infinity. And wherever, if it's going to be shifted 1 unit to the right, remember the domain was from 0 to positive infinity. Since it was shifted 1 unit to the right, it's now going to go from 1 to positive infinity. And the range is still going to be all real numbers. The next example, if you want to graph this logarithm that still has a base that is 1 or greater. Now we have x minus 1 inside the parentheses, so that's going to shift it 1 unit to the right, and then plus 4 outside the parentheses, that will shift it 4 units up. So again, starting with that marker 1, 0, 1 unit to the right would add 1 to the x coordinate, 4 units up would add 4 to the y coordinate. So where the point 1, 0 was, will now be at 2, 4. Alright, and as you can see, the domain is the same. It's still from 1 to positive infinity because it was shifted 1 unit to the right. And the range is still all real numbers. And the last example has a base, a fractional base. So we are adding 3 inside the parentheses. That will shift it 3 units to the left. And we have minus 4 outside the parentheses. That will shift it 4 units down. So that starting point 1, 0, 3 units to the left will, if we subtract 3 from 1, we get negative 2. And then 4 units down, we subtract 4 from the y coordinate 0, we get negative 4. So that graph is being shifted 3 units to the left. So now the domain is going to go from negative 3 to positive infinity. And the range is still going to be all real numbers.